Hello, Algebra 2. Miss LaHart here, coming at you for Chapter 7, LT6. I can identify the trigonometric functions using x and y coordinates and evaluate who's positive in which quadrant. Okay, so back to the unit circle because this is where we live for a little bit. If you were to draw yourself a triangle, okay, within the unit circle, triangle, this is the x distance, this is the y distance, and this is one unit because we're dealing with the unit circle. So then we start thinking about the ratios of the trig functions. So this, if this is theta down here, the y would be the opposite, the x would be the adjacent, and that one would be the hypotenuse, of course. So let's start doing SOHCAHTOA. So sine is the opposite y value over hypotenuse 1. So sine is the y. Cosecant is the reciprocal of sine, so that's 1 over y. Whoa. Cosine, probably get where I'm going with this. Adjacent over hypotenuse is x over 1. Therefore, secant is 1 over x. Tangent of theta is opposite over adjacent, which means the y over the x value, and the cotangent is the reciprocal. Oh my goodness, let that set in. I memorized it to a tune. And it's not like a tune, it's just like sine is the y, cosine's the x, tangent's the y over x. It's just like a little ditty, if you will. Sine is the y, cosine's the x, tangent's the y of the x. And then all the reciprocal functions, you just flip them, okay? So pause the video and write that down. It's a huge part of today's learning target. And get out your unit circle, because here we go. All right, so now this stems to reason that there, are certain trig functions positive in certain quadrants. So let's bring those back up here so we can see those. Okay, now let's remind ourselves who's positive where within the quadrant. So we got x is positive and y is positive in 1. X is negative, y is positive in 2. Well, both are negative in 3. Positive x, negative y in 4. Okay, so this yields itself to some of these being positive. So who's positive where? It's a party in quadrant 1. Everybody's positive. Everyone's positive in quadrant 1. Quadrant 2, only the y value is positive. So that would mean that only sine and cosecant is positive in quadrant 2. Negative and negative. The only way to get a positive is if you divide a negative by a negative, which means tangent and cotangent is positive in that quadrant 3. Quadrant 4, we got the x is positive, which means cosine and secant are positive. Okay. Usually we do ASTC, which stands for, well, the acronym is all suckers take calculus, but sine, tangent, cotangent, and the reciprocals that they belong to are positive in those quadrants. Okay. So pause the video and write any of this down. Because now we're going to talk about, name that quadrant. So if I give you certain criteria, can you tell me what quadrant I'm in? And again, you got to kind of know what an inequality notation is. That you learned quite some far away. So cosecant is less than 0. And I'll pull up my diagram on the right here. Cosecant is less than 0 means that it's negative. So where is cosecant negative? So I have to go off of where it's positive and then go in the opposite direction. So cosecant is going to be positive in 1 and 2, meaning it's going to be negative in 3 and 4. So I'm just going to put a little smiley face to delineate that we're talking about quadrant 3 or quadrant 4. The next one, cosine being negative. Okay, where's cosine negative? Well, cosine is positive in 1 and 4, meaning it's negative in 2 and 3. Where do I have my 2 smiley faces? Quadrant 3. And that's how you got to do it. Okay. Next one, another example. So the first one we got sine is positive. So we know sine is positive in both quadrant 1 and quadrant 2. Secant being negative, okay, we know that it's positive in 1 and 4. So that means it's negative in 2 and 3, meaning quadrant 2 is the winner. Okay. You can do smileys, you can do check marks. I don't care what you do. I just like to, delineate what we're talking about so that way I can compare who has the most smileys at the end. You try. Pause the video and try this example. All right, here we go. So cotangent being negative would be in quadrant 2 and quadrant 4. Sign being positive would be 1 and 2, meaning quadrant 2 is the winner. And that's how you do those. Okay. The last bit, you're going to need your unit circle. You're going to need your unit circle to help you because that'll be a lot easier to reference. Okay. We have sine as the y, cosine as the x. Now, I can't do every single example out there, so I just want to make a couple points. Remember that 0 divided by 1 is 0. Okay. Whereas 1 divided by 0 is undefined. Again, I can't do all the examples, but just in case that comes up, that might happen if you're talking about the quadrantal angles like 0, 90, 180, and 270. But just so you know. Okay, so here we go. So find the exact value in simplest form of rational denominator, 270 degrees. So you take out your unit circle, find 270 degrees, and then you know that the sine is the y value. So what is the y value at that coordinate point? -1. So sine of 270 is -1. And it's as simple as that, folks. Find where you are in your unit circle, write down what trig ratio you're working with, and that's it. Okay, let's do another easy example. 135, cosine of 135. So again, cosine is the x value. Go to 135. What is the x value? Negative radical 2 over 2. Winner, winner, chicken dinner. So cosine of 135 is negative radical 2 over 2. Right? Try tangent of 225. Pause the video and try this example. Right? 225, boom. Negative radical 2 over 2, negative radical 2. Tangent is y over x, but if you put anything over itself, if you divide anything by itself, it's going to be 1. Boom. Okay. So those are necessarily your easy examples. So now let's talk about the reciprocal ones. These require a little bit more work. Okay. So if it's the reciprocal, you're just going to flip the fraction. Reciprocal, you're just going to flip the fraction. If you're working with tangent or cotangent, you do sometimes have to divide two fractions together. So I just want to remind us what the rules are for that. So it's keep, change, I guess. You keep the first fraction, so a over b stays the same. You change division to multiplication, and then you multiply by the reciprocal. So instead of c divided by d, we're doing d divided by c, and then you multiply across. Okay. I was going to use numbers, but variables is easier. So you just keep, change, or whatever you guys remember from that. You keep the first one, change division to multiplication, and multiply by the reciprocal. Okay. Find the exact value of secant of 315 in simplest form. So secant is the reciprocal of cosine. So x, we're looking at our x value. So our x value for this is radical 2 over 2. Because we're dealing with the reciprocal function, we take that fraction and flip it. We use the reciprocal. Okay. However, it does say simplest form with rational denominator. So I can't have a radical in the denominator. So you got to multiply top and bottom by the radical itself, multiply across, simplify if you can. So 2 divided by 2, you're going to get just radical 2. So the secant of 315 is just radical 2. Okay. So when you're dealing with the reciprocal functions, just take your fraction and make it the reciprocal. And then most often than not, there's a radical in the numerator, so you're going to have to rationalize the denominator. Okay. Secant 30 degrees. Secant, again, the x value. So we're looking at radical 3 over 2. So I use the reciprocal of that. And now I have to get rid of the radical in the denominator. So radical 3 times radical 3, moving on over, you get 2 radical 3 over 3, final answer. Okay. Now we're going to do a tangent one with the, all the reciprocal or all the fraction work. So here we go. Cotangent 330. So 330 is here, and cotangent is the x value over the y value. So you can see I've pulled it up here. So you change it from radical 3 over 2 divided by -1/2 to radical 3 over 2 times -2 over 1. You multiply across, you simplify what you can so the 2's can eliminate. So you are left with the answer of negative radical 3. Okay, so that's why having your unit circle, having those diagrams labeled will help you out. So let's do the you try. Go ahead, pause the video, try this example. Okay, here we go. So sine of 120, again, sine is the y value, so that would be radical 3 over 2 at 120. Find the exact value of cotangent of 180. You can do your reciprocal, your quadrant angles. So that's the x over the y. So you would get negative 1 over 0, which is undefined. Okay. And that's, my friends, why we needed our good old unit circle. Peace out. Have a great day. Missile Heart out.